When talking about convergent and divergent sequences, it is often useful to talk about the behavior of what is called the tail of the sequence. And so in this video, I want to define what we mean by tails. So let's let this guy be a sequence. And I'm going to let capital N be any specific natural number. The so-called entail of our sequence is the list, and it's going to start with the nth term of our sequence, and then it goes on to the next one and the next one and the next one and so on. And this is often written as the sequence of pk, as k starts at capital N and goes to infinity. In other words, it's all of the terms, so the entail consists of all the terms with their subscript being bigger than or equal to capital N. So if my original sequence looks like this, P1, P2, P3, all the way up to Pn minus 1, and then we get to Pn, and then we get to Pn plus 1, and we keep going. This part here is the entail. And we clearly have an entail for each natural number. And so it's important to basically simply think about that entail is a way of talking about what happens to the sequence as the indexing term, as the subscript gets bigger and bigger and bigger. It is also important to realize that for any entail, there are a finite number of elements that are not on the tail. So there are a finite number of elements, or actually technically I should call them terms. So there are a finite number of terms that are not in the entail. Now, there are a couple of other things that I want to talk about as far as these tails are concerned. And the first one is just an observation. If little m is strictly bigger than capital N, then the little m tail is a, well, I'm going to not define this particularly yet, but we can think of it as a subsequence of the capital entail. And I basically just want to kind of think about how I would write this. So we've got P1, P2, all the way out to Pn minus 1, and then we've got Pn, and we've got Pn plus 1, and we keep going until we eventually wind up at Pm minus 1, Pm plus 1, and the thing keeps going. And what I want to notice is that this much is the m tail, and this much is the n tail. So clearly the m tail is got fewer, well, it goes further out, so it's a smaller sequence, so to speak. Anything that is in the m tail is in the entail. And that's the idea of this subsequence that we're not really going to be formally defining yet. But the idea is that if pk belongs to the m tail, then pk has to belong to the entail. The final thing that I want to mention in this particular video is that we often just refer to the tail. So we often refer to the tail of a sequence. And when we're talking about just the tail of a sequence, what we're simply saying is what this means is that there exists an entail. Well, I should say there exists a capital N, such that the entail does what we want it to do. So such that the entail somehow behaves in the desired fashion. So in the way we want. And that's all that I want to say about tails right now, except that in the next video we're going to see that thinking in terms of tails lets us digest the definition of convergent sequence and divergent sequence in a little bit more informal of a way.